I'm Justin Riak. I'm the Chief Architect at Rogue Wave Software. I focus mostly on our emerging open source technologies that we like to focus on. As a company, we provide services and support for community editions of open source packages. So we do not branch, we do not proprietarize, we allow you to get the software from the community, and we can provide you with support. In fact, this presentation comes out of a 3-day comprehensive training that we do on Node.js. So please feel free to get in touch with me if you're at all interested in anything like that, and I promise that is the last sales pitch you will hear from me. So what are we going to solve today? Hold on. No, just kidding. Nobody likes the spinning wheel of doom or the spinning wheel of hope. So we're going to talk about how we can use asynchronous processing to be able to return requests back to our users faster. Node is inherently asynchronous. And for anybody who hasn't worked in a language that is inherently asynchronous, it's difficult. It's going to be a bit of a shift in the way that you think about the way that you're writing your code. But this really is ideal for the way that things are done now, right? We're living in a world of distributed computing. Moore's law is no longer being maintained by clock speeds, right? We're not seeing huge increases in clock speeds. We are seeing major increases in the number of cores that we can shove into a system, and we've taken that a step further and abstracted it all out, and now we're looking at microservices running in parallel inside of containers. Maybe we're spawning 5,000 replicas of a small machine learning process to spin up for 20 seconds and read some data and spin back down. And when we're doing all of that work in parallel, we really need a way to distribute that code and make that code very atomic. Anybody who's familiar with the concept of a 12-factor app, probably if you're working with containers, you're starting to learn some of those fundamentals. Node is actually an ideal language for doing something like this because it is inherently asynchronous and it's very small and very lightweight. It is built on industry standards and it's been vetted against thousands of production systems. It's an extremely popular language right now. So what else are we going to solve? This is probably the more valuable part of working with Node.js. So in the past, this is what a development process or team would look like, right? We'll have back-end servers. These are exposing data or services to front-end applications or front-end servers, right? And maybe we're writing these front-end apps in HTML and JavaScript and CSS. And so we have our UI developers who are familiar with JavaScript who are writing this part of the code. Meanwhile, we have another silo, right? Our back-end servers. These are our back-end APIs and back-end systems. And maybe these are getting coded in PHP or Perl or Java, right? So this should look pretty familiar for anybody who's done any type of development over the last, say, 15 years. But now we can do this. Now we can have a DevOps team only code in Node.js. We have an app farm, and our app is served up from both the back end and the front end using JavaScript, using Node.js, okay? That's an important concept here, right? So people who have been good at doing JavaScript development for a while can now be more useful at doing back-end development. We can do back-end and server-side development in JavaScript, which is very useful for the way that we're sort of converging our development teams these days. So this allows us to code our front-end and our back-end using a single language, okay? Which, if you think about this in terms of agile methodologies and Scrum, it's a lot better when we're having a Scrum meeting or something like that, and the technical folks in that meeting are all capable of understanding and speaking the same language. So a little bit of an overview of the language. By the way, stop me at any point if you have a question. I'll do my best. It was created by a guy named Ryan Dahl in 2009, and really was just created mostly to deal with these concurrency issues that we were talking about before, right? So when we start thinking about distributed compute and parallel compute, we have to start rethinking the way that we write code. We need that code to be useful when it's concurrent, right? A single JavaScript process is single-threaded by default, right? We have one engine, in this case the V8 Chrome engine, which is our JavaScript interpreter, and that is a single-threaded process. But as we'll see in a moment, Ryan Dahl sort of famously, over the weekend, built a layer between the V8 engine and the JavaScript interpreter. And we'll see a picture of that in a minute. But it's built on Chrome's V8 JavaScript engine. So again, this is important. When Node.js does not use its own JavaScript engine, right? It uses an industry standard engine. But what it really does is layer some tools in front of that engine that allow us to do concurrent coding. And if that doesn't make sense right now, don't worry, it will in a minute. We'll see a picture. It is single-threaded, asynchronous, event-driven. We can achieve vertical scale by adding additional CPU cores. And there are actually conventions within the language where in just a couple of lines of code, you can tell Node.js to fork off a certain amount of worker processes to match the number of available processors on the server in which the code is running, so it can auto-scale to an environment. Again, very ideal for something like a container environment where we may not necessarily know the sizing of that environment. And we can use JavaScript on the browser as well as in the server, which is going to minimize this mismatch between the environments. So for instance, I can do all of my form validation in a single app, as opposed to having to do form validation on the front end and then repeat that validation again on the back end. There's a list of registered subscribers, which are basically just node processes, and they are notified when their state changes. Okay, so you have a pub sub or a topic-like pattern happening between worker nodes and a master node, and that master node is able to communicate down to the worker nodes, and the worker nodes can communicate back up to the master using a topic kind of pub sub methodology. We also have NPM. This used to be called the Node Package Manager. Now you're just supposed to pretend that the node doesn't stand for node anymore because this has become a general sort of JavaScript module repository, but the vast majority of these modules are for node. So anybody who's familiar with, maybe pip in Python or CPAN in Perl or NuGet in .NET, you already know what NPM is. It's just a package manager for installing dependencies for your node applications. As of February 2017, there were over 400,000 total packages on NPM. However, as of April of 2019, that number has doubled. And there's no question now that NPM is not only the fastest growing module repository and dependency repository out there, but it's also the largest, compared even to things like Maven Central right here for Java. Right, so any Java developers like myself who are using Maven, you're like, oh, there's a lot of modules in there. Yeah, well, NPM has, almost 4 times as many at this point, and continuing to grow very quickly. So just sort of a general overview here, sort of pros and cons of using Node. On the good side of things, it is very lightweight with an extremely low memory footprint. It is a true cross-platform environment. In that server and client-side code can both be written in the same language as we talked about before. It is very fast. Its asynchronous nature allows it to be just about as efficient as it possibly can be. It is very popular, gaining lots of popularity right now. I think it has sort of the same appeal that a language like Perl had in the late 90s, right? This shared repository of well-written dependencies. But it's just a little bit more advanced of a language, right? But I think that's why it's catching fire the way it is. There's already a lot of people who understand JavaScript, and so to make the transition to Node is just not that difficult. You need to learn a little bit more about the additional modules that you can use in Node and learn a little bit about NPM. Get familiar with some subjects like semantic versioning and things like that. But overall, if you've done JavaScript development, it's pretty easy to make this transition. It is full stack web development, and it's highly extensible. Now, on the bad side of things, the V8 engine does have a 1.7 gigabyte memory limit, okay? That means that we have to have multiple V8 engines processing in parallel if we want to be able to use more than 1.7 gigs of memory within our application. And again, we can do that by taking advantage of Node's clustering functionality. So this makes a vertical scaling challenge, but workarounds do exist. Module versions can get a little bit confusing. For the most part, people are conforming to semantic versioning, which does make your life easier, but not necessarily. Open source governance is not flawless. If anybody's familiar with the left pad debacle from a few years ago, this was a really big deal. There was a module in Node. It was like 18 lines of code. It was a very small module. And the purpose of that module was to insert spaces, left tab spaces, so that you could align text. This thing was used all over the place, all right? Tons and tons of apps were using this. The maintainer got angry and pulled the module off of NPM, literally breaking the internet. It's a very interesting story to read, but a good reminder for everybody that you have to be careful about your use of open source. Open source is the best thing in the world, but you have to govern it. You have to manage it. You can't just go wild with it. And definitely a learning curve for developers who maybe aren't used to dealing with a language that is inherently asynchronous. Again, it's a different paradigm. It really feels different when you're coding. You know, you expect your code to just execute one line, like you're used to with a synchronous language. But in this case, that's not happening at all. Node is absolutely going to skip ahead in your code and execute things further down, even if it hasn't finished the asynchronous action that it had before. We do have ways to make this a little bit easier. We have like promises and closures and things like those patterns if you're used to that. We now have a relatively new functionality that was introduced in ECMAScript 2016, I think, called async await, which allows us to pretend that our code is a little bit more iterative. But just again, you know, be aware that's probably the biggest challenge for people who are just coming in to JavaScript and to Node.js is wrapping their heads around this sort of inherent asynchronous nature. Here's a web-enabled Hello World app. So again, this is a web-enabled one. We're actually creating a back-end web server here. Okay, so as opposed to just printing something out to the command line or whatnot, we're actually spinning up a lightweight web server that's called just basically the HTTP module that ships with Node, and that HTTP module allows us to create a small HTTP server, respond to certain requests, and then push what we want to. And of course, we tell it to listen on a particular point or port. Okay, so this is interesting, right? This is JavaScript creating a back-end web server that can service requests. All right, that's different. JavaScript's usually served up by a back-end server. It's not usually the back-end server, but again, that's fundamentally what's different about this. Very high-level look at the architecture and what kind of makes this different. And so I said before that the creator of Node.js, Ryan Dahl, built this thing over the weekend. Well, if you look at the architecture here, you can kind of see how that's possible, right? Down here, this is the V8 Chrome engine. This is the actual JavaScript interpreter. This is not written by or maintained by the Node.js community. This is the industry standard JavaScript interpreter. But what have we done here? We were asking our app to pass commands through the Node engine. This is proprietary to Node.js. We have some miscellaneous libraries that we might hit to access the operating system. Okay, we've just fundamentally shifted here from what we're used to with JavaScript. JavaScript's not supposed to be able to know anything about what's going on at the operating system level. It's sandboxed to the browser for security purposes, right? You wouldn't want somebody able to just access or just run some arbitrary JavaScript code on your laptop and give them access to your operating system. But Node, of course, has to do that because it's running on the back end. So it has some special libraries specifically for accessing things about the operating system level. Then we have this interesting thing here called libuv. Libuv is a very fast event loop. It's an event loop that was created in C++ specifically for Node.js. Now it has found some use in some other applications as well. It's completely open source. But this is the magic. This is what makes Node.js so different. I'm passing commands asynchronously down into an event loop. That event loop is asynchronously taking actions against the engine or against the operating system and returning things back to the application. This is how I'm capable of having a distributed application that could actually spawn multiple instances of the V8 engine to allow this to allow the code to execute in parallel. All right, so it is literally spawning off multiple V8 processes on the server to go and service a single JavaScript action. Okay, so you're writing code, and when it executes, that action actually goes into its own isolated V8 engine instance and executes and then returns something. So this does a couple of things for us, right? So first of all, it makes it very easy for us to be concurrent. In general, as long as you can wrap your head around the asynchronous semantics of the language, you shouldn't even really have to think about this. It just kind of works that way. It also makes it inherently thread safe, okay? Because V8 itself is single-threaded. And because we're running these multiple JavaScript actions inside of isolated, separate V8 instances, they are running in their own thread. They are thread safe inherently. Another way of looking at the same architecture, Here's our app, passing commands into V8. Here's these special Node.js bindings. And here's this event queue. And it really just is a queue, right? It's a loop. Events come into the queue. They're read off the queue in a loop. If we have a blocking operation, like a database read or a file system read, then this will block. But that's OK, because the next event queue can be sent out into another instance of V8 and execute in parallel. Okay, so this is where the magic happens. But if you look at this and this, these two pieces here, we're just kind of stapled on to JavaScript, and that's how Ryan Dahl was able to create Node.js in a weekend, right? He didn't really write that much code. He just kind of put together some libraries that made sense to work together. So, for the most popular programming language out there, with the biggest number of dependencies and modules out of any other language, it's pretty impressive that he really, just kind of cranked the thing out over a weekend. It's a very smart guy if you ever get a chance to meet him or talk with him. He doesn't like conferences, and he's not a big public speaker, but he does attend some of them. If you get a chance to hear him or speak with him, I highly recommend it. He's a very smart guy. Okay, so how do we actually get Node going on your system? Well, it kind of depends on your operating system. If you're dealing with Linux, if we're using Linux, which you probably should be, most of these open source technologies were built with Linux in mind, and then maybe backported to like a Windows environment. Mac is kind of the exception, right? We're running BSD, so it's Unixy enough. It does run on Windows, but why? There is an official Docker image as well. And a standalone shell script installer. So many options to install it. If you're in a Linux environment, this is the easiest way to do it. It's usually just yum install Node.js or apt-get install Node.js. Once it's been installed, we want to make sure that our package manager has been installed as well. And we can validate that just by checking the version of each binary from the command line. So here we are just saying node-version, cranking out an old version. I need to upgrade it on my Mac. And then we're seeing that npm is installed as well. And if that runs, your code's going to run, because these tools are written in Node.js. All right, so let's do a quick Node app. It's enough theory for the moment. We're just going to do a super simple console hello world app, and we'll do it from scratch. Then we'll execute it on the command line. So I'm just going to set the mic down here for a second. So a couple of things to note on this. If you're reminded at all of Perl, Python, any of these languages that feel almost like scripting languages because we can run them right from the command line without having to do a build necessarily, right? You should be reminded of that because you can, all right? Now, if we have dependencies and things like that, which most of our more complex apps are going to have, then there is a build process using npm. But all that build process really does is download these modules, which don't have to be compiled, right? They're just being interpreted by the V8 engine, all right? So you get to just kind of start real quick without having to do a whole lot of planning. without having to worry about a bunch of build files and stuff. And for the most part, the IDE is going to do a lot of work for you. So we're doing on time here. So we're going to speed up just a little bit because I want to make sure we can get through all this content. I really like VS Code for Node.js development. I really do. Microsoft is surprising everybody right now. In fact, this shirt says open source, and it's a Microsoft shirt. Okay, the world's changing a little bit, and VS Code is a great little IDE, totally free and open source. And the preview editions give even cooler new functionality. So you can do things like remotely develop via SSH on a remote server and stuff like that. It's pretty great. Terminal integration is essential when you're building your Node apps. In fact, on that demo, I didn't even open an IDE, right? I just went right into VI and just threw something out there. The built-in debugger works flawlessly with Node.js. It's really a nice experience. It just works. And you do have other options, though. Go with what's familiar and go with what's available and is not Notepad. That's critical. So we've all got our preferences when it comes to IDEs, right? Maybe you're already familiar with something like Eclipse. That's fine. There's Node.js tooling for Eclipse. Maybe you prefer an online IDE, something that's integrated already with Docker and maybe gives you a container environment. Well, you have that too. Just want to make sure that you've met these basic criteria when you're picking this IDE. You really want the debugger, obviously. You want syntax highlighting. You want it to support what's called ESLint. For those that don't know, JavaScript is not really JavaScript. The specification is actually called ECMA script or ECMAScript, and that's where that ES comes from. So you want ESLint, and if you've ever used lint before to clean up your code or to check your code for syntax, it's basically what it's doing. We want terminal integration, we want NPM integration, we want code completion with IntelliSense, we want a beautifier. We do want Docker integration these days. It's just a lot easier to get started with Docker. We want Node modules integration, which we'll look at in a minute. And we want our source control integration. Hopefully we're using Git or something like that, and we're not just, saving our program in a zip or something. But you do have some other options when you want to look at an IDE. This one is actually pretty cool, I have to say. This Cloud9 IDE, it's completely online, and so it's kind of cloudy, basically. All your code's going to get stored up in the cloud, but it does have Git integration and all that kind of stuff. You can push all your code out to your GitHub. Live preview. JetBrains, if you like the IntelliJ experience, if you're a Java developer, JetBrains does produce one that's similar called WebStorm for Node.js. Komodo, and then NodeClipse. If you like Eclipse, then you can just get the Node.js plugins for Eclipse. So plenty of options here. I just really like VS Code, so we're going to focus on that. We have a bunch of VS Code extensions for Node.js when we search for it up here. You can see we've got our debug and really just a bunch of stuff. And there's a whole lot of plugins for the various frameworks and dependency libraries that we can use with Node. So things like Vue.js or AngularJS or React. There's a lot of tooling that's built in for that as well. I have another talk on React, which unfortunately didn't get accepted at this one, but I will be giving that talk at the OSS Summit in San Diego in August. Start with at least Node debug and the Node.js extension going. Take time to explore what's out there, though. In VS Code, we have a launch file that's specific to VS Code. All right, this has nothing to do with Node.js. This is telling VS Code how to launch our app, but this is essential if we want to be able to debug our app. Okay. The launch configuration is controlled through a JSON file called launch.json. Code launches, and it basically just describes the environment, bootstrap information for the app. If I want to set some environment variables, maybe this is where I would do that. But it is essential for debugging because your app is going to get more complex. You're going to need some stuff set up in your environment before you can run your app, like an environment variable or whatnot. Maybe you're using OAuth and you need a client key. I don't know. You're going to be storing stuff in an environment variable. And it won't launch properly without that environment variable being set. So you need to tell VS Code what the environment should look like. And you do that in this launch.json file. So let's take a quick look at the debugger. Okay, so we'll start. I'm setting breakpoints just like I normally would in any IDE. We'll go ahead and set 2, one at the very beginning, even though it's kind of useless, and then 1 afterwards so that we can check and introspect the contents of our variable, okay? When you get started with Node, you're going to spend a lot of time in here, all right, in this debugger, because it's very easy to look at the way that the Node.js object notation works. It's very easy to kind of see how functions, like every object is actually treated like a function. Functions are first-class citizens in Node.js, so I can pass them and I can set them and all that. Get more into that. I have an advanced talk on this. So let's just run this. Let's look at our launch configuration. Okay. So we stopped at our first breakpoint, and we can already see that we've got some useful stuff in here, and I realize that's kind of hard to see. Let me... So I'm not going to go into the contents of all of this right now, but I do kind of recommend you poke around in here because you're going to get to learn a lot about what Node's actually doing in the background for you. But we can see that we have defined our constant. It just hasn't been set yet. Currently undefined. So let's move to our next breakpoint. And great, we can see that our variable has actually been populated at this point. We could introspect it. We can set a watch point on it. Really anything that you'd expect to be able to do in a debugger we can do here. All right, pick up the pace just a little bit. All right. So we've seen just a quick hello world that you can get started with very easily. And now we've had a little preview of what we can do in terms of our developer, our debugger in our IDE. So this is the basic life cycle of a Node app. We're going to create and clone an SCM repo, hopefully. Again, hopefully we're using source control, like good people, right? But if not, you can just create a folder. If you're going to use Git, set up your ignore files and whatnot. You want to initialize the project. This is the best practice. I haven't done that yet. The very last demo shows that. But npm init will set up a file called package.json that we're about to see. And that's like your build file. That's where all your dependency information is housed, as well as some meta information about the app itself. npm init will set that up for you automatically. And a lot of IDE plugins and extensions will do that too. Then you just get to it, start coding, commit as normal, and then build. So in our target production environment, we're going to run this npm install. That's going to download all of our necessary dependencies. When we see our package.json file in a minute, this npm install will actually go out to the npm repository, pull all the modules down, which is effectively the build process for Node, because again, we're not compiling anything. This is what the npm init kind of looks like. So you see it's going to prompt you for some information, things like a Git repo, author, your license, which should always be GPL3. And then it's going to generate your package.json file based on that. We just talked through all this. Yes. Okay. So now let's turn this into a proper Node application, or what we should really be calling a Node module. Even large Node applications are still considered a Node module, right? This just comes with your Node tooling, right? If you've installed Node, you should have the npm tooling as well. That I have this script in there. I'm just going to kind of leave all this blank. But this right here is the package.json file. All right, so let's say it's okay. Yes. And when we cat it out, hard to type with one hand. Then this is what we have. Now, in just a minute, I'm going to kind of rush through a little bit because I want to show you the very last part, which is working with external modules in npm. but all of that dependency data is held in that package.json file, which again looks like this. So our apps can use dependencies or modules. Remember, everything in Node.js is a module technically. Most open source languages these days are going to have a set of modules that can be added to a project. Node is no different. You can also create your own modules, whether privately or freely available. And the NPM repositories would actually provide these. And it can be used to add dependencies to a project by, again, using this npm install command. But it's not npm install blank like doing the whole build like we saw a second ago. This is actually installing a particular module. So let's see what that looks like. So let's add a little color to our app. There's a module for Node just called colors, and it's for doing colors like what ANSI generated color codes in the terminal. You want it to be readable and even fun. And as you start working with more and more Node.js apps on the command line, you'll find that people actually do care about this. Like they're putting cool little UTF icons and stuff in their code and putting colors in and everything. If we run npm-save, that will actually make sure this module is saved to package.json so that when we distribute it to our production environment and we run npm install, those modules will be downloaded into our environment. So here we're just saying npm install --save colors. And then in our code, we can now require the colors module. And now we can use this syntax to make something like red and underlined. So let's take a look at that real fast, and then we'll wrap it up. So again, we're saying npm install --save colors. Notice all the pretty colors. Okay, now what did that do? We've got our package.json file, and now we have this new folder called node modules as well. And this is, unsurprisingly, where our modules just downloaded to. So if we do a quick ls in here, we can see that the colors module downloaded. And if we pick this up, it's just another Node.js module. It's just written in Node. If we look at our package.json file, we can see that we now have a dependencies section in here, and it automatically picked a version for me. And I can use semantic versioning syntax here if I want to enforce some stuff. And then at this point, if we run npm install, even if we don't have that node modules folder, it'll go and download that module for us again. All right. So the final picture. Here. And there we go. All right, so we just imported a dependency and used a module. And that actually wraps us up. So what did we learn today? We learned that you should carry your clicker with you when you leave the podium. Node.js is a language that focuses on concurrency and unified development under a single language. Dependencies are assisted through the Node Package Manager, which is no longer called the Node Package Manager. It is asynchronous by default. A lot of IDEs exist. You should initialize your projects using npm init. You can install modules with npm install. They're built from package.json when we install in a production environment. And they're included in variables using the require command. But there's still a lot to learn. So go learn about understanding asynchronous coding. It just takes practice. Get to know the events and streams inside of Node. Learn about functional programming. This is very much functional programming. Master your IDE's debugger and start exploring other modules. And finally, feel free to reach out to me. I do get lonely. And I promise you I will accept your LinkedIn or Twitter or any of that. I do get a little political on Twitter, though, so if you're easily offended by hippie politics, then maybe don't go there. That's it. Thanks.